here. Yep, the first 12 ones. What's the index of the first term in the fib sequence to contain 1000 digits? Yeah. Okay. All right. Like this one here, can we solve this in JavaScript? I guess because we can always use big integers, but getting to a number that contains 1000 digits, that's a big number. I don't know if we can solve this brute force. So the 12th term is the first one containing 3 digits. 1000 digits is long. Yeah, those are too mathy. They're not really what we're looking for in an interview. Oh, were you asking about TypeScript in general or TypeScript with the cute little quokkas? So we use TypeScript for a bunch of the client libraries, and it's super useful because instead of looking up everything in the documentation, you have type hinting by the IDE if you use the client library. So if you're just a user of the library, it makes it much easier. You're like, oh, that's what the function is called, and that's the order of the parameters. And it makes refactoring easier, makes it easier to spot bots. But if you're just trying to prototype something, or if you just want to hack in a small change, I can find it quite annoying, especially if you have very strict TS-lint rules. Okay. All right, so for next week, I'll make sure I have a problem that takes a little longer than 15 minutes to solve. Also, again, if you have suggestions, send them my way. Maybe it's a good problem for the stream. Oh, okay. Kai is saying I can solve it in JavaScript without runtime issues, but I have to use big-int. Yeah, I was thinking of big-int, otherwise it wouldn't fit. Well, should we solve it? Should we do one more? Kai, this is on you. If like the brute force approach doesn't work for this, then we're messed up. All right. So let's try this. What's this called? N-digit fib number. So oh, cool. You moved it to TypeScript. Very cool. All right. So we have a function n-digit fib number, and it takes the number of digits. And let fib is equal, so we need our generator function again, which I closed. So fib.js. Let's copy and paste it over. Oh, we just want this one time. Let generator equals fib. Let current equals dot next dot value. Oh yeah, we have to yield 1, but we want big integers. So we have to do big integers everywhere. If we're adding big integers, we get big integers. Okay. Okay, so you say just a few milliseconds. All right, let's try that. How do I find the number of digits in there? Do I just JavaScript begin number of digits? I guess that's not a function. I have to check if it's bigger than something. So I've big int. Yeah, I think the split to a string might work. All right. So I do want Coca now. Let's reload Coca. And how do I turn on Coca for just this file? Oh, is it still off? Coca, enable, reload. Do I like always need to start a new file? Well, we tried to start on current file. Oh no, we did this on every save. Okay, start on current file. So if I do console.log of current, nope, it's not on. Identify directly after number. What's that even supposed to mean? Oh, I think it doesn't understand big integers. But 1015 would know that, right? Yeah, but it says no 1015. And so here if I do like 1015 knows big int. Very confused why it can't handle this. What if we do big int of 1? Okay, so you're saying plus equals last and last current minus last is invalid syntax. Tell me where. Okay. All right, so weird. So it understands big int, just not the short notation. But since we don't have to write it all the time, I think that is fine. So why don't I see that now? Shouldn't it tell me what current is? I thought we got this to work before. So start on current file is the right thing to do, right? Like, seems to be okay with it. Anybody else using Coca and knows what's going on and why I don't see anything? Oh, maybe because I'm never running this function. Could that be? Okay. And this is completely useless. Sorry, Coca. Also, it seems to be kind of, oh, because I have to do. So I get 1, 2. Okay, it is enabled, but it just says big int. Can I do like a big int that value or something like that? A that to string. Okay. Dot value dot to string. Okay, so that works. Cool. Okay, so we can get the Fibonacci numbers, and oh, and if I do toString, I can even see the length of it. So while true, I can also tell that it's a tiny little bit slow. Like it still says true is not defined, but I clearly know how to spell true. Okay. If current length is bigger than 3, console log current. Hey Quokka, please update. Okay, could I see this value? Now it seems to be off again. I need to watch fun functions videos to see how he uses it as successful. Because I don't get the little squares anymore. Maybe it's just slow. Let's give it some time. So what I would like to see was number 104, I believe. If we look at this one, 144 should be the first one where we have more than, no, if we have more than 2, that's what I want to see here. Sorry, and I forgot to break. So here we could say while current length is, no, I'll leave it the way I had it. So I run this, and then if, actually I want to see those. Okay. And I need to update this. All right, so current at length doesn't seem to quite work. Current is a string and length is the hardest word to spell. Okay, yeah, so this will stop at 144. So now we don't want it to be bigger than 2. We want it, oh, okay, now it works again. So for 3, 4, gee, that's gonna be such a big number. So once the length is bigger than this, oh, that's really neat though. It is right here and I don't need to run it. Anybody know why this didn't work before? Is it just a little slow? Okay, so client friend is saying, does the length need to be 1 off because of the n suffix? So I'm not printing the, I'm not using the big int directly, I'm using big int to string, and the to string gets rid of the n again. Oh yeah, I can't see anymore, but so those get printed without the n, so the length is exactly what we want. But I'm 1 off because I'm stopping the first time that I'm bigger than 999. So I'm stopping as soon as I reach 1000. I don't think this answer is gonna fit. Oops. Have I copied and pasted? Copy. Okay, maybe copying doesn't quite work in here. So let's run it. I'm really surprised that this is so fast. Aren't we running this like a lot of times? Okay. Oh, this code is hard to read. 5, 6, 3, 4, 6. Did I get this right? 5, 6, 3, 4, 6. Nope. So what did we do wrong? Oh, thank you. It's not asking for the number that is 1,000 digits long, but it is asking for the Fibonacci term n. Oh, thank you so much. Okay, so here it wants 12 and not 144. All right, let's fix this. So let I equals 1. This is the first one, and when we're increasing I, we also need to, when we get the next one, that's when we need to do I. And so here we don't want to log a current, we want to log I. That looks a lot simpler. And again, copy and paste, that's a pain. I copy and paste this, yeah, that works. And then the answer code is 10354. I++ doesn't change I. I'm pretty sure I++ changes I. Pretty sure I changed that. Yeah, I know it's Saturday, but I++ changes I. Okay, but not quite correct. All right. So when is this bigger than 2? Okay, I'm off by 1. Why am I off by 1? I don't understand. I is equal to 1. 1, 2, 3. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. How is this 12 over here? Oh, because they start with 1, 1. All right, we can fix that. So if it's 1, 1, 1, 2, where did the 3 go? Here. All right, let's fix that. It's kind of double in there, so I want to yield last current. Okay, now we get the 12. So now if we do 999. Okay. Yeah, thanks, Finn. And yes, I was off by 1, figured that out. I don't want to print that anymore. I just want this number. Hi, Coachy QQ. Yes, generators, and they work. I just found out about them. Well, I knew about them, but I didn't realize how good they can be for recursive functions. So you can easily use generators for recursive stuff, and then down here just always work. Oh, we should rewrite that to be a little nicer. Yeah, but yes. Okay, let me rewrite that as soon as this is right. Yes, I'm just off by 1. 6, 6, 6, 4, 8. Check. No! Why is that not correct? Well, at least yours is correct. Mine doesn't work. What is the index of the first term in the fib sequence to contain 1,000 digits? Why did this not work? What did I do wrong here? So, first one with 3 has index 12. I wasn't off by 1, but by 3. How could I possibly be off by 3? If it works for 12. Yeah, Kai, I'm confused too. So, let's see the fib sequence. It's 1, 1, 2, 3. That looks perfectly fine, right? Let's write it like this. If the length is 3, then this is 12. If the length is 1000, 4782. Isn't that the number that I put in? 4782. Yeah, that's the number I put in, and apparently that was still wrong. Getting 2 different answers, okay. All right, I'm pretty sure, yeah, 4782. F12. Am I supposed to write F4782? No, what's the index? So if I do 2, first one that has 2 digits is 7, that also works. And you're saying maybe I copied and pasted this wrong? 4782. 4782. There's nothing on the left here, it's just 4782, nothing on the right. Did I mess up the code? And it wants 1000 digits. Like, we all have the same problem, right? No. I just reloaded the page. Maybe that makes a difference. So 47. Oh, you know what? These are like weird numbers that it copied. Because if I type it, go away. If I do 4, it doesn't like give me that pull down. Am I making sense? So maybe copying and pasting from Quokka. Yes, okay. So I think what's happening is, oh, where's the Quokka output? How do I get that Quokka output again? Run once? No. Yeah, I was copying this number and somehow that was not regular numbers. Oh yeah, I still have it saved, I think. No, I don't know what I'm doing, but somehow the input was kind of, I think it was a weird thing because the dropdown didn't work when I typed in a 4. All right. Oh, and I guess we're only calculating 4000 fib numbers and we're doing that in a linear fashion. That's why it's so fast. What I don't like is how we're using the generator here. So I think I want to say for const f of fib, and we don't need this, for const current of fib, and then if current at length is 1000, then we break out of the for loop. I think this is a little bit nicer. So this is basically our while true, except that we're always getting a current number, and then if we are long enough, we're printing this. Yeah, I think it's something weird like that. Uh-oh, did I mess it up? This is taking too long. Yep, I messed it up because current is the value and I need to do current dot to string that length? Nope. Current dot to string. Come on, show me what it is. Oh, I never increase I, thank you. Maybe that's already doing it. Yep, okay. Thank you, that was a really good hint. Okay, yeah, so our code looks super nice. We just take the current one of Fibonacci, const, should we call it n, f? Why do we even have this n here? Oh, for the length equal to this. So let's just say for every number in the Fibonacci series, take the toString because we're using big integer. This is something we have to do since they get so long. And if those have 1,000 digits, then we log it. We see the number right here, and we keep increasing this I. Yeah. Yeah, thank you, Drunk Punk. That was helpful. I was refactoring too quickly and forgot to move the I around. And this is the generator function, which kind of works like an asynchronous function. Like it returns here and then later picks up where it left off the last time. So the first time it returns the last value. The second time you call it, it won't run these 3 lines. It will start right here. So it will return big end of 1. And then every time you run it, it will yield the current in this while loop and then always take off, start where it left off the last time. So really nice for these iterative kind of things where you then want to do something with the result, and you can just use a for loop like with anything that's iterable, and you get them number by number by number. Okay. Somebody is saying current at value. No, I don't need the value because when you use it in an iterator like this, you're already only getting the value. We had to get value before because we weren't using a for loop. Is current now the iterator or the iterator result? It is the value of the iterator. Okay, and Kai is saying check out problem 19. I guess we could do that.